So modularization, we have the first thing that we have in modulation is the include programs. Second one is the subroutines. Third one is the function modules. Function modules. So include programs, subroutines, and function modules. Include programs are global modularization, global modulation technique. So what exactly is modulation is uh, writing or developing something, writing a logic once and using it multiple number of times. So this is a simple concept of modulation. You develop something once, or write the logic or develop something once, and then use it once, multiple number of times. So develop once, use again, again and again. So as simple as that. So in this, include programs are one of the modulation technique, and subroutines are local to a program, local modularization, and function models is global, global only. Function model is global. These are the modulation techniques that we have. Okay, so these are the things that we have: global modulation, local modulation, and then we have this function model also. We have this global modulation technique. So we are going to first make use of include programs. So you might have gone through include programs in your previous logic codes that you used to write in C, C++, or something like that. So if you have that background, you can recollect that you were using include in the hash include at the first line. So what exactly include is all about is it has some pre-declarations which can be used in our program, as simple as that. So if you have any pre-declarations in the include program, we can just add that in the top of the program, and those all declarations will come into your program. So that's something which we have. And in ABAP, we have less number of include programs, but more number of function modules. So function modules are exclusively used. So what is function module? What are function modules and how they are being used? I'll explain you about that. But before that, we'll just go ahead with this concept of include programs now.
Sir,
Oh, so actually, like we have this. Oh, I was on mute. Sorry. So let me do it from the beginning again. See what I said. What I just said is we can write some logic in the include program, and that logic which we write in the include program can be used in any number of programs. So what I just did is I maintained this include program here, which can be used by all of us. Like, we have, if we are 50 people, all 50 of us can use this you know this include program in our programs. That's what we have. So let me create it as include 2, and we need to do this as something like delivery include, any description of your choice, but here it is mandatory for us to give it as include program here, and just click on save local object, and then here we have to write this logic here. Oh, this logic. And once you have activated this as in the include program, this can be used in any number of the programs, and once you use it in any program, you don't have to declare all these things. Let me add one more thing: tables likp lips. So we have this. So these are the things that we have here. Okay, so we just need to activate this include program, and once we activate this include program, this include program can be used in any of the programs. So let's create a program and make use of that in that program. Okay, let me copy the program include name here. Now we'll go for project. We'll go ahead with include and that program name, that include program name. After that, we can directly write the select options. We can start from the select options. The code we can write from the select options in our program. So we'll go ahead with the select options. From select options, we'll write this logic. So we have not maintained the text here. I'll just comment it. See, so this particular program can be executed, and execute. So we'll get this data in this. So now we don't have to write the logic here in every program. So whatever is common for multiple programs, which you think that is repeated, you can just add that in the add that logic in the include program, and that include program in turn can be used any number of times in our program. So if you see a standard program, let's say I go with MK01. This is vendor data, simple screen. Okay, this is MK01. Now we'll go to system and status. Going to system status, you can see the program name here. So we'll go for this SAP MF0. Okay, double click on it. So if you see this program, this is entirely like included I mean, like entire program is in include programs. Almost all standard programs will be like this. An entire program will be written in include programs. Each include program again has some logic. So why they do it is mainly because if they will be having a plan of using that code in multiple number of programs. That's the reason we have this. And then we can see in which all programs this has been used. So these are all the programs in which that include program is being used. Okay, so SAP has like got most of the code written in the include programs like this. But we don't use much of the standard include programs. We use a lot of standard function models in our customized programs. In customized programs, we don't use much of the standard include programs because function models has an option of giving some input and getting the output process and all these things. We can get it in the standard standard function models. So you have subroutines here. Subroutines is a part of modulation technique in which it is local modulation technique. Local means within the program. So in the within the program, what we do here is like we write something called perform. We write something called perform, and I'll give something like SR1. So some SR1, and then for this perform, we need to have a form SR1 form SR1 end form at the end of the program. So at the end of the program, we have to have this end form. So form SR1 end form. So in between this, you can write some logic here. You can write the logic. So this perform statement can happen any number of times in the program. This perform statement can come any number of times in the program. So how many times in whatever places we are calling this, we are using the perform. This form, whatever logic we have written, will be executed here. Okay, so this is what happens. So there can be any number of instances where within the program you can call it, and whatever logic which you have written here in the form and form will be displayed here. This is what is the concept of subroutine. Okay, so we'll do a simple logic here. We'll create a simple program in which we use perform and form statement, and then we will see different possibilities of going ahead with the different types of forms, and we can also pass the parameters. So how to pass the parameters and all also we'll see. In which I'll just normally write perform something like SR1, and then I'll say, then I'll double click on SR1. Task subroutine SR1 does not create, does not exist. Do you want to create? If you say just yes, then you'll say main program. In the main program, say okay. And this is the form that gets created automatically. And this is only one time creation, only once it gets created, and we can call it any number of times. So write calling second time, and then we'll say perform perform SR1. Okay, so SR1 we are calling it second time. Okay, so here we'll say, just say write simple logic. Okay, we'll give it as something like I am SR1 subroutine. I'm SR1 subroutine. Okay, so now we just call it calling second time, calling first time. You can say calling first time, calling second time, calling third. And then calling third time, perform SR1. So we are having this like this. So we're getting this calling first time, second time, and third time, and just activate this. Now let me put slash here. So when you execute this, we're saying this calling first time, I'm a servant subroutine, calling second time, calling third time, and all this. So this is what we have, and we can just write the skip. Okay, so what we're trying to understand here is that a subroutine is something which can be written once and called multiple number of times, as simple as that. So we can have complex scenarios of subroutines wherein we pass parameters and we have a lot of complex code that can be repeated number of times and number of times in our program. There can be import parameters, export parameters, and we can be changing parameters and tables that we can pass through this subroutines, for which we'll discuss with the examples of these routines. Okay, so we'll do that. This is a simple modularization example. Function module, simple function module. So now what exactly is the significance of function module is it can be it can have parameters. A function module can have parameters. Of course a function subroutine can also have it, but this is a global modularization in which we can have import parameters, we can have export parameters, we can have changing tables, that's the internal tables, exceptions, and source code. So these are the 6 options that we'll have in a modularization technique. So we will use one simple example of say c is equals to a plus b. So if you want to get c is equals to a plus b, then in this example what would be the import parameters? Means import in the sense giving it to the system. So what are the import parameters that we have here? The import parameters would be a, a comma b. What is the export parameter that we have? C. And what will be the source code? C is equals to a plus b. So this is what we have. Now c is equals to a plus b, for which we have export parameters c, input parameters are a comma b. So this is what we have. So let's go ahead and do it now. And in this simple example, we are not taking care of the changing exceptions and tables concept. So these 3 we are not taking into consideration now. C is equals to a plus b. We're just having this import parameters, export parameters, and we have source code. Let's do a simple function module for that. So for doing this simple function module, any function module can be done in SC37 transaction. We have to build it in SC37 transaction, which is called function builder. Now, before that, we need to have a function group. function group. We need to create it in the SE80 transaction. We need to create a function group. So this is what we have. So function group is like a package, kind of a kind of a package for all the function modules. For example, you have a function group. If you have a common logic, then we have to write it in the function group. So in the function group, we can write the common logic, and then we have function module fm1, fm2. So in this function group, we'll go for something like z dxe underscore function group 1. So this under one function group, we can have multiple function modules, function module 1, function module 2, and all this. Okay, so this is what we have. So function group, under one function group, we can have multiple function modules. And this function module, if there is a common logic that we have to write for all these function modules, function module 1, function module 2, if there is something which is common which we have to declare, we can declare at the function group level. And this function group, we have to create it at SE80 transaction. SE80 transaction. We have to do it in SE80 transaction. So function module will be creating a SE37 transaction. No matter how many function modules are there, we'll create in function module. So remember, without function group, you cannot create a function module. Okay, and just like a package is just a name, function group also is just a name that we have to declare here. This is what we'll do now. Now let's go to SE80 first, create a function group, and then we have to save it another, and we have to create a function model in SE37. And when we go to SE37, we'll create this A and B as the input parameters, C as export parameters, and source code will write the C is equals to A plus B. This is what we'll write. And in this, we'll give all the properties of this as we'll go ahead with the properties of A, B, and C as some property like data element. We'll assign something like we'll assign the property as numc underscore 5 or something, in which like this is a predefined data element which will have the length as 5 and type as numeric. Okay, so we'll give it to for A, B, and C. For all the three, we'll give the same properties. So what we have to do now, we have to first create a package, the function group. So let me also create a package here because we don't have it here. So we'll right click on this, create a function group. So in fact, like you can also create it like this. Instead of that, we can also select here the function group, and we can create something like Z Vikramaditya ZVA underscore FibG1, and you can click on create. So yes, G1. So in this we have these things. So by default, this everything will be there in this. So we have to just right click and activate. Once you have created this, you just need to activate this. So once it's activated, we can go ahead and create a function module. So for that we'll do it in SE37. We'll create a function module in SE37. So in this we'll go for ZJH underscore Z Vikramaditya underscore something like add. Simple function mod group called add. So now it's mandatory for us to give the function group. ZVA underscore FG1 is the function group that we have created. So this is sum of two numbers. So just say okay. So this warning will come for sure for everyone. Nothing to worry. This is not a error or something. By default, it will throw an error that by default it will show an message that this function module is reserved. So we'll just say okay. Here we'll go ahead with the import parameters now. So as we have discussed in the theoretical part, import parameters a comma b and export parameters c. And for all we'll give it as numc underscore 5. So here I'll give it as a type numc underscore 5, b type numc underscore 5. Then export parameters, we have c type numc underscore 5 source code. C is equals to a plus b. C is equals to a plus b. Now we'll execute this and we'll have the value of a and b. So the value of a is something like 12, b is 15. Execute it and you'll get the value is 27. So as simple as that. So what did we just do? So we gave this import parameters as a and b and export parameters as c, and then source code we have given as c is equals to a plus b. That's all we have done, nothing else. So we need to give some parameters here. So that's the reason we are given it as numc underscore 5, which is a predefined data element. Export parameters also we have given this because we have to declare some properties. So c is equals to a plus b is what we have given in the source logic. And when we execute this, we can give 10 and 15 and execute. You'll get the value of c as 25. So this is at the function module level. And if you have to call this into a program, you have to just create a program and call it that. Simple. I can do it from SE80 or SE38. If you all guys are comfortable with SE80, you go with SE80 because it's easy for us to see everything in one place. So we'll have a package, right click on this, create program, ztxe underscore, say zva underscore, function module from add. So here, if we have to call that function module, we just need to click on this pattern and we need to add the function module name that we have done here. And what is the function module name? zva underscore add. So we have to give here zva underscore add. So this is how we call a function module. So once we have called a function module, let's go ahead with something like data parameters, p underscore a, type numc underscore 5, p underscore b, type numc underscore 5. So we are giving the values in the parameters, and data declaration should be above the parameters. That's how we do the declaration. So once we have to complete the declaration, so I'll give something like k type numc underscore 5. So here we'll write as p underscore a is the input, p underscore b is another input, and exporting we just uncomment these things and we'll give it as k, because k is what we have declared here in the program. So we can declare c also, we can declare some other field also, anything. So when we say write sum of two numbers is comma k. So once we have this, syntax check, activate, execute. If I have 10 and 12, execute, and you get sum of two numbers is 22. So you get it. So since we have to give some input, I have declared it in the parameters. If you would have declared that in the data also, it would have come, but we should have again given some fixed values here. For example, a is equals to something, b is equals to something. We need to assign that values, and then we would have got only a fixed value. But right now, since we have created in the parameters, we can give some values, input values to it, and you'll get the output of the this function module. In SAP ABAP, we have a lot of predefined function models with complex logic. Just like we have done in the previous program, we have used um, GUI underscore download, wherein we actually have downloaded the downloaded that file, right? Similarly, we have a lot of standard function models, but this is a user defined function model that we have here, which is actually can be used for our um, for any of the function models. So there are thousands and thousands of function models. For each purpose, we have a different function model. We just call them and we can make use of that in our programs. Okay, so is it clear now? So 19th project would be the menu painter uh, with the option to download the data into a notepad. So this is what we have. So we have to create a report to display the bill of material data, and you all know that it's MEST table, which which we have already used in the program, and then enable the customized menu. So we all know that we have to create a customized menu in SC41 transaction, and going there we have to enable that options, and then we have to also enable it to download the output into a local drive. This is what we have to do. That can be considered as a 19th project. And the 20th project would be based on function modules, which will be done in the next session. So these are the projects that we have covered.